If we take a look at example number 4, and we think about the vertical line test, and I draw a vertical line right here, you'll notice the vertical line hits here and here. That means that it has, and if you think about what the coordinate point is, I know you can't really see that, but this would be 1, approximately 4, and this would be 1, negative 4, sorry, negative 1, negative 4. And you'll see that there are repeats in the domain going to 2 distinct values of y. So this is not a function because it fails the vertical line test, and you can see how it repeats the domain. As far as the domain goes, again, we're looking at the x values. You'll notice that there is no graph over here or over here, but it's continuous from here to here, which is approximately -2 to +2, and it's continuous because at every value it's somewhere on that graph. And our range, there's nothing above this number, which we'll just say is approximately 4, and there's nothing below it. So our range goes from -5 to +4. Now, something you might also see, and you might be familiar with, is mapping. Sometimes they'll use charts to denote it, and this is basically our domain and our range. And there might be elements, whether it's figures or numbers or variables, and basically they'll give you a set, and they might give you some numbers here in the range. And they would just kind of show you that if I put in 1 into my function, the end result is 3. If I put in 3, I get 5. And if I put in 2, I also get 3. And basically then you can think about that as ordered points. 1, 3, 2, 3, 3, 5. And you'll notice that because the domain doesn't repeat, even though it's being sent to the same range, the domain stays the same, so it would be a function. And finally, we would do the same thing if we were just given equations. So you would basically kind of think about what the graph would look like. You can make a sketch and figure out what the domain, range, and if it's a function based on that. So if we think about this right here, number 5, y is less than 3x plus 4. Here we have an intercept, slope of 3, dashed line, but it's an inequality, meaning it's shaded. So would it pass the vertical line test? It actually wouldn't, because if I drew my vertical line here, because the shaded region, these are all points within that domain, therefore it would fail because it's being sent to different ranges. It wouldn't be a one-to-one function then. So this would not be a function, and the domain and range would be all real numbers, kind of similar to what we saw in one of the previous examples. And finally, number 6, 1 over x. This is a function, and if you're unfamiliar, you can always take your calculators to look at what that would look like. They kind of have asymptotes right here. This is a rational equation. The asymptotes occur at the axes. As you can see, it will approach but not touch. So it would be a function because they technically don't, they pass the vertical line test. The domain and range will be a little bit trickier. It would go for the domain, well, and the range as well. Going left to right, it starts at negative infinity, and it goes almost to 0, but doesn't include 0. It skips over it, so we won't include it. And then it joins together, so it's a union. And then over here, it's approaching 0, so but not included. and then goes to positive infinity. The same can be said for the range. It's going down, approaches 0, never touches, skips it, and then goes to positive infinity.